Welcome all. In this video, we present our project COVID detection using deep learning. Group members are Shilpa K. Prabha, Swetha S. Shenoy, Najitha Arangodan and myself Athira A K. The early detection of COVID-19 is crucial to reduce the transmission rate and slow down its spread. RT-PCR is the gold standard for detecting COVID-19. However, the RT-PCR test has a low sensitivity and requires a special kit, and it is very time consuming. Compared to RT-PCR, CT scan images have a high sensitivity in diagnosing and detecting cases with COVID-19. The COVID CT scan is a chest scan used to monitor the conditions of lungs and other respiratory organs. The main objective of our work is to develop an advanced and robust deep learning model to classify the CT scans into three classes of COVID-19, CAP and normal cases.
Coming to the top level block diagram of our model, SPGC COVID-19 dataset is used as the input, which includes volumetric chest CT scan of COVID-19 CAP and normal cases. This dataset is pre-processed before being fed into the CNN model, including resizing, image normalization, and further data is augmented by flipping, rotating, and translation of images. After data augmentation, the output is fed into the CNN model, where the convolutional layer extracts features from the image and dense layer classifies accordingly. In training phase, the CT images are trained to certain number of approaches in order to classify them into COVID-19, CAP, and normal cases. The accuracy and related parameters of trained model are tested in the evaluation phase.
Now coming to our model, we have proposed an automated system for diagnosing COVID-19 from volumetric chest CT scans. The proposed model was built using the modified AlexNet architecture. The architecture consists of 8 layers that includes 5 convolution layers with a combination of max pooling, followed by 3 fully connected layers, all of which use ReLU activation except for the output layer, which uses the softmax activation function. Overlapping pooling was used in the model since it was found to reduce error and also prevented the model from overfitting. The model was trained on grayscale images of input size 512 by 512. Out of 7,493 images, a total of 5,394 images were used for training with batch size of 64 and learning rate 10 raised to minus 4. ADAM was used as the optimizer and images were trained for 40 epochs. Early stopping was used here to keep track of the model's generalization error and to stop training when it began to degrade. The figure shows the curve of model accuracy and loss during the training. Due to the early stopping, our model training got stopped after 20th epoch. The training accuracy was obtained as 95.78%, validation accuracy 98.44% and test accuracy 98.03%. Here, confusion matrix was calculated to visualize the performance of the model and give an insight into the data. The other evaluation metrics such as precision, recall, F1 score and accuracy are calculated using this confusion matrix. The overall F1 score and recall was obtained as 0.98 and average precision 0.99.
The proposed model was also compared with other pre-trained models such as Inception V3, EfficientNet, VGG16 and DenseNet as shown in the figure. Since this is a real-life classification problem and there is an imbalanced class distribution, so here the F1 score is a stronger indicator of incorrectly classified cases than the accuracy. And among the architectures, AlexNet model was found to have the maximum F1 score and Inception V3 was found to give the worst performance. The project is demonstrated using a simple web application built on Python Flask server. The DICOM file is sent to the server via a file input. The image is displayed and there is also a slider for zooming in and out. The proposed model evaluates the CT scan image and predicts the correct multi-class output, that is COVID, CAP or normal, and the prediction result is displayed on the screen as the server gets ready to predict the next DICOM file. That's all. Thank you for watching.